Hi guys, Dr. B here. This is topic 1.4 for AP Chemistry, composition of mixtures. The learning objective is to be able to explain the quantitative relationship between the elemental composition by mass and the composition of substances in a mixture. When two or more pure substances, elements, and compounds are combined, they form a mixture. In mixtures, the composition can vary. The mixture can be analyzed to determine the mass composition of each substance in that mixture. Got to do some stoic to be able to convert the mass of the products to the analysis to find the amount of reactants, etc., back and forth. So you should know how to do stoichiometry. If you don't, then you're going to struggle with this. This is a concept technique you should know how to do already coming into this class. The mass percentage of a substance in the mixture can be calculated with the following. Mass of the substance divided by the total mass of the mixture times 100 will be the mass percentage of that. Elemental analysis to determine the composition of a mixture can be qualitative to identify the different elements present, or quantitative, the amount of elements present. Some examples of elemental analysis. CHNX, used by organic chemists to find the mass of, so notice the letters here, carbon, hydrogen, nitrogen, and other random elements such as halogens or sulfur. Spectroscopy, optical, light is passed through a colored solution. You'll learn about this in 3.13 Beer-Lambert law. Mass spectroscopy, which we already covered in 1.2, and then photoelectron spectroscopy 1.7. So different ways to analyze, and we're going to learn about different ones later on. Aluminum metal reacts with the air and forms a thin corrosive resistant coating of aluminum oxide, Al2O3, according to the following unbalanced equation. One of the things you need to remember is whenever you're solving an FRQ problem, something like this, you have to double check that the coefficients are balanced, or the equation is balanced. Sometimes they'll tell you it's unbalanced, other times it is balanced. You just have to double check, and that's just one less thing to worry about. In fact, sometimes a part of a question, like part A, for example, of a 12-part question, can be get the right coefficients, blah, 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 blah. So it could be an easy one. Example of a mixture of aluminum and aluminum oxide weighing 120.9 grams were analyzed, and the total mass of aluminum in the sample is found to be 120.32 grams of aluminum. Balance the equation provided. See, that's one question. It would say, what are the coefficients? So we have Al plus O2 produces Al2O3. We have two Als, we have two O's, and we have three O's. So I'm going to put a 2 in front of here, distributes, it's going to be 3 O2's on the other side, so 6 O's on both sides, then 4 Al. What mass of oxygen was in the sample? So you're going to take the total mixture, 120.91 grams, and subtract 120.32 to give you 0.59 grams of O2. Aluminum reacts with the air. Oh, sorry about that. What mass of aluminum oxide was in the mixture? So we're going to take the mass that we had of oxygen, 0.59 grams of O2, convert that over to aluminum oxide. 1 mole of O2, 32 grams of O2. It was 3 moles of O2 converted to aluminum oxide, so 2 moles Al2O3, 1 mole Al2O3 on the bottom, and the molar mass of aluminum oxide, 101.32 2.96 grams of Al2O3. You do your math, you multiply the numerators, multiply the denominators, divide the two, and you should end up with this right here. So 2 sig figs, so we had 1.253, so we only have 1.3 grams of Al2O3. What is the mass percent of aluminum oxide in the total mixture? So the mass percent, let's see. So 1.3 divided by, grams, divided by 120.91 grams times 100. You end up with 1.075, so it will be 1.1%. The main component of eggshells is the compound calcium carbonate. If you react eggshells with acetic acid from vinegar, the following reaction will take place. If 4.421 grams of CO2 is produced from 10.57 grams of eggshells, what percentage of the eggshells was calcium carbonate? So this is the total mass. So we're going to save this later. We're going to take the 4.421 grams of CO2, convert that all the way over to calcium carbonate. So 1 mole of CO2 on the top, 44.01 grams of CO2 on the bottom. Actually, double check, are we balanced? Yes, we are. So we have 1 mole of CO2. Lucky for us, we have 1 mole of calcium carbonate, 1 mole of CaCO3 on the bottom. Get the molar mass. Should be 100.09 grams of calcium carbonate. Do your math. Multiply the numerator, multiply the denominator, divide the two. You end up with 10.0544. So we have 4 sig figs. So we should have 10.05 grams of CaCO3. We're not done yet because it's asking for what is the mass percentage. So we're going to get the mass percent calcium carbonate. It's going to be 10.05 grams divided by 10.57 grams times 100. 95.12%. So this means that in this mixture, about 95% of it was calcium carbonate. All right. So if you have any questions, please let me know. Hit the like and subscribe. Thanks. Bye.